Okay guys, I'm really having some technological problems here getting this screenshot software to work on my version of the newer version of Windows that we have in the office. So please bear with me, this is not going to be perfect, but at least I want to show you how to use Crystal Ball once. You'll get a chance to do this in your groups on Wednesday. So the first thing we want to do is tell Crystal Ball which of these input parameter values are random, and we want to assign we want to characterize their distribution, assign information to tell Crystal Ball how to draw values for each of these to use in each replication of the simulation. So the parameters, the 4 parameters highlighted in red, I just highlighted and changed the color of the font, are the ones that we need to work with. And then this last one, the expected cost for the week, is the outcome variable that we care about. So to work with Crystal Ball, what we want to do is click on the cell for the first input parameter, the number of tasks that need to be completed in a week, and define assumptions. You're not going to see this very well. Okay, this is the distribution gallery. It's a handy way to start learning about these distributions. Got on it by defining assumptions in Crystal Ball tab. And since for the first 3 parameters that are red, all we know is the most likely value and then a range, the min and the max. And so if that's all I know, and I think that it's most likely that the values are going to be close to the mean, the 12, 6, and 7 here. Well, not quite 6 and 7, I'll change those. I want to use the triangular distribution. It's a really good one to use when you don't know much other than you know the min, the max, and the most likely value. So if I click on triangular, now I get a pop-up menu that walks me through putting in information about the triangular distribution. And I hope you can see this in its entirety. You can do this yourself. I'm going to type in the min, which was, in my case, I made a note for myself, 5, and the max is 20, and the most likely is 12. So I'm going to type in min 5, most likely 12, and the max 20. And then I click OK, and Crystal Ball turns that cell green, and that means that we've defined it as this input parameter. We've characterized the distribution around this input parameter, and it returns an average value, the average of the min and the max. Okay. So now let's go and do the next one, the number of tasks completed. Remember the min and the max are 1 and 6 here. Define distribution. Again, let's use triangular. Min is 1. Max is 6. Okay, the most likely is the average of those, which is 3.5. But this is technically not correct here because these tasks are actually not continuous random variables. So let's go back and change that. Let's go back and look at the gallery. So since the triangular is going to draw a value that is anywhere between the min and the max, then that's not technically right because we have a variable that is only going to take on integer values. I can't do 1.2 tasks, so that's not a good distribution to use. So let's now consider the discrete uniform. This is also a pretty good basic one to use. What it means is every value between a min and a max are equally likely. So again, the number of tasks to be completed, that ranged from a min of 5 to a max of 20. So let's type in 5 for the min and the max 20. Hit OK. Okay, we can talk more in class about why I wanted to change from the triangular to the discrete uniform, but it has everything to do with wanting a distribution that was going to draw only integer values, not values like 3.2, which don't mean anything in this context. So I want to change now the distribution for the number of tasks completed on the weekday. Go back to define assumptions. Here I've still got the triangular, which I started with, but I don't want that, so I'm going to click Gallery to go back to the gallery, scroll down, click on Discrete Uniform. Again, the min and the max in this case are 1 and 6, so we'll type in 1 for max of 6. It's going to show me what that distribution looks like. If I hit Enter, that looks good, so I'm going to click OK. Now the next one, this is the number of tasks that get done on the weekend. The min is 2 and the max is 12. Define assumptions. Let's do the discrete uniform again. Min 2. Okay, max 12. I always forget. I have to look back there. Enter. There we go. Click OK. The last parameter is this one, which is, are the tasks done high quality or not? So define assumptions. This value can only take on one of 2 values. So this yes, no is a good one. Now, It's not going to work though because it's going to return a 0 or 1. So we need to go back to the gallery and let's create a custom distribution. This is one that we make up. So we're going to say we have to start entering the values. Well, 1 is a value, and the probability of 1, let's just say for now that I think the kid is equally likely to do all tasks high quality. So I'll say 0.5, hit enter. Now I've got 1, and let's put in the value 2, the other value that this input parameter could take on. Remember, it's a 1 or a 2, and something has to happen, so the probabilities have to add up to 1. So now they do. It's either going to take on, now with 50% probability, this value is going to be 1. With 50% probability, it'll be 2. Hit OK, and that's good. Now I want to click on the outcome variable. We've defined all input parameters. I want to click on the outcome variable, and now I click define forecast. Okay, and this tells Crystal Ball that this is an outcome that I care about. So if you click on that, give it a name. It's got a decent name already. Units, it's dollars per week. We just want to give it a unit name that makes sense to us. Click OK, and notice that Crystal Ball changes that color. All right, now we want to run the simulation. So we're on the Crystal Ball tab. Let's click Run. Number of trials or iterations is 1,000. That sounds good. Remember, you just want this to be a nice high number. The higher the number, the better the information we're going to get about the distribution of the outcome variable. But also the higher the number, the longer it takes to run. But since this is a small model, it'll go pretty quickly. So I like 1,000. Let's click Start. Crystal Ball's running it. And now I get, hopefully you can see this in its entirety. Let me shrink it so you can see it a little bit better. Okay. Now I get information about the outcome variable in each one of these 1,000 runs of the model. I notice that the mean is 100. Well, dollars per week. Sorry, the mean is probably somewhere. We can process a lot of this information now. Crystal Ball gives us a histogram right now to look at, but you can see that on the x-axis this is the dollars per week, the expected cost, and this is the probability. So the way to look at this is that there's about a 3% probability that the expected cost will be $5 a week, about a 3% probability that the cost would be $6 in the week, and so on. So the mean cost is probably somewhere around $15. In class on Wednesday, you'll get a chance to start processing this information a little bit better. Your book walks you through how to process this information in Crystal Ball. But for now, what I wanted you to see was how to run the simulation. So we're going to stop here. Went through this quickly. You'll get to practice this on your own computers on Wednesday, and we'll keep doing this over the next several weeks. But I wanted to show you this quick example for now. Okay, I'll talk to you all soon. Bye.